So far we have seen one way of solving this geometric problem where a triangle ABC was to be constructed from the given altitude 30 mm over here, the angle at the vertex 50 degrees and the sum of these two sides AC and CB. We knew nothing about the base, neither its length nor its orientation. We solved this problem by starting with vertex C, plotting the loci of A and B 100 millimeters each, the given sum of lengths, at 50 degrees, the vertex angle. And then we drew a parabola which was tangent to these two loci and a circle with C as a center and radius equal to the given altitude. The base was then found to be the common tangent to the circle and the parabola. So knowing these two loci and the orientation of the base, we could complete the triangle. We had taken a kind of semi-analytical approach where we found the focus of this parabola and the tangent at its vertex, so that instead of the curve we could talk in terms of points and lines. Then we marked these distances which bore a certain relationship, this quadratic equation, which we solved to get these two angles. This angle gave us the orientation of this radius at the point of tangency, and thereby we could find the common tangent we were looking for. But what about the second solution of this quadratic equation? Let's see. Let us plot the second solution, the angle 103 degrees, thereby obtaining a radius. That radius will give us a point on the circle. At that point, we will draw a tangent to the circle and we will extend this tangent upward till it meets the axis of the parabola. We will extend it downward till it meets the tangent at the vertex of the parabola. So we are going to get this tangent segment between the axis and the tangent at the vertex. Now we know that the length of this can be doubled to get a point on the parabola. Then this will become a tangent at that point. So we are going to extend it, sort of double its length this way. Then we'll be reflecting it on the other side of the axis, and this gives us a control polygon. Using this we can draw the parabola. We are drawing the same parabola, in fact, a kind of extension of what we just had. And now you will see the interpretation of the second solution, the 103 degrees that we had. It is indicating again a common tangent to the circle and the parabola, but instead of being an internal tangent, it is kind of a external tangent. So this too should give us the orientation of the base. So using that side, that common tangent as the base, and these two loci of A and B as the other sides, let's complete the triangle. So this is the triangle. Let us interpret this triangle that we obtained in light of our original information. Here was the locus of point A. You'll see A is now situated on the extension of that locus. Here is our point B, situated on the extension of the original locus of B. The lengths over here can be marked like this, and then you would see the length here is 48.37, length here is 148.37. So instead of the sum of these two lengths, AC and CB being 100, their difference is now 100. That is true for this angles also. Instead of this internal angle at C being 50 degrees, we are getting the external angle at C to be 50 degrees. So we have kind of got a inside out triangle, an inverted triangle. Instead of internal, we are getting external angle. Instead of sum, we are getting the difference. And this can be explained by saying that our quadratic equation is treating these lengths not just as mere line segments, but vectors, directed line segments. And in that case, this length here is directed in the opposite sense, and therefore this can be treated as a negative length. And if you treat this as negative length, well, its sum along with that is bound to be 100. And even this angle will be measured on the outside of this triangle. So everything falls in place, and this also becomes a solution.